Dear learners, welcome again to our channel. Today we want to look on the concept of the normal move out for the reflection on the horizontal interfaces. What does this concept mean? Well, if you are doing geophysical survey, assume on the surface, this is the surface, you will set the source and set receivers along the profile line, and assume that it may be from the surface, this is the layer with a certain thickness, let's say h. If it has the distance, the thickness h, and this layer. If you release seismic signals, of course they will be traveling, they strike on the boundary, they get reflected to the geophones, they strike on the interface, they get reflected this way, this way, this way, this way. These are seismic signals which have been released from the source, and these are the geophones separated with a distance. But what does the normal move out mean? It has been observed that these seismic signals which have been released, when they strike on the interface and change the direction moving to the surface, they will of course be received to different geophones. But it has been observed, though these reflected signals are coming from the same reflector, they won't arrive at the same time on these geophones. The geophone which is very closer to the source, will receive first, and then the other one. And the geophone which is at the largest distance from the source, it will receive the signals more later. What causes this? This is caused by the difference from the source to the geophone distance separation. And the total travel time difference is known as the normal move out. We know that the travel time is given as x over v squared plus 2h over v squared. The time squared is equal to x over v squared plus 2h over v squared. This is the equation that describes the total travel time for the reflected seismic signals. But if you want the total travel time at any distance from the source, let's say x, then it will be expressed as dx is equal to x over v squared plus 2h over v squared, and then raised by 1 over 2. You apply the square root each side. This is generally the expression for the travel time of the seismic signals towards any geophone, given by the x as the distance from the source to a certain geophone. Therefore, the normal move out will be obtained by the normal move out is the difference in the travel time between the travel time to the geophone at any distance from the source and the geophone at exactly position of the source. I mean x is 0. So the difference is known as the normal move out. And this can simply be given as the x over v squared plus 2h over v squared minus At x is equal to 0, then t0 will be given as 2h over v squared, then raised by 1/2, it will be 2h. If you subtract, you get 2h over v. And this is the expression for the normal move out up to this point. Thanks for listening. Keep subscribing this channel and follow other concepts.